My name is Vladimir Vivien. I'm a software engineer from VMware, upstream Kubernetes contributor. Today I want to talk about distributed application on Kubernetes, specifically native distributed application on Kubernetes. You've probably seen this quote somewhere on the net from Kelsey and others, that Kubernetes is a platform for building platforms. What I'd like to add is Kubernetes is a platform for building distributed systems. I mean, if you want to build a distributed application, Kubernetes has all of the ingredients that you need to do so, from resource management, a solid scheduler, automatic process distribution scaling, built-in fault tolerance, available stream clusters of events, distributed data store for state synchronization, et cetera, et cetera. The state of the art to build a distributed application on top of Kubernetes today is controllers. They're a control loop that synchronize cluster states from desired state to actual state. They interact with the API server, and it's a proven abstraction that's been around with Kubernetes probably since Kubernetes started. However, it's designed to extend Kubernetes itself. It wasn't necessarily designed to build on top of Kubernetes. It exposes a large API surface, and a lot of it has to do with structural concerns. And it requires the intimate knowledge of Kubernetes working. About a couple years ago, operators were introduced to kind of mitigate some of that. They hide the complexities of raw controllers, and they can be used to build Kubernetes applications. A lot of time, operators are used as runtime application management automation. It's a powerful abstraction on top of Kubernetes API. But to me, they come with the same sharp edges. You still have a large API surface to deal with, and it still requires you to know a lot about the internal working of Kubernetes and now the operator API. As a software developer who's interested in building a native distributed application on top of Kubernetes, what I want is a small API surface that I can reason about, complete abstraction of the inner working of Kubernetes. I don't care how the sausage is made, right? No assumption about the Kubernetes API knowledge is made. It turns out that we've had a tool that's been doing that for a long time. It's kubecontrol. kubecontrol exposes its own API to the human, us, and it hides all the complexities of interacting with Kubernetes. You don't know what's going on in the back end. You just type kubecontrol run and something happens and you're happy. So I want the same thing, but in a programmatic form factor. So an experiment I've been working on for the last about year and a half is a simpler API that exposes an event-driven interface, leverages existing Kubernetes API objects and resources. It introduces nothing, nor does it take away anything. And it has a split design of a coordinator which launches, coordinates, and monitor worker processes. And those worker processes implement application logics for your distributed application. Now, if that sounds like something you probably are familiar with, like an actor-like approach, it is. It's kind of inspired by that. So let's take a look at a simple coordinator that launches a worker process and talks to the worker process and does something with it. They exchange data. Very simple for this 5-minute talk. First, we'll create the coordinator, give it a name, namespace, and a configuration so it can talk to the API server. Next, we set up our callback function that will get triggered when a pod event happens. In this instance, I'm interested when my pod that I'm going to launch becomes ready, and when it does get ready, I want to talk to my pod via HTTP. Then we apply a cluster operation. In this instance, I just want to launch something. I want to run a process. And that's what we're doing. We give it a name, an image, a port, some kind of image pull policy, and that's it. Then we start our coordinator. The worker side of things looks similar. And here is where we apply our business logic for what we want to run. We create the worker, we specify another callback event. And in this case, we want to know that when the worker is ready, we create a server, a simple HTTP server, and then we start the worker. Then we deploy our application, in this case, the coordinator binary, just like any other Kubernetes binary, Kubernetes application. Now, once my coordinator runs, it launches the worker pods for me. And then, as you can see in the bottom, they talk to each other. The coordinator is receiving events from the API server, and it's parsing it. So this is something, again, this is completely POC running on my laptop, and hopefully it'll be open source soon. I want to add more services and functionality primitives, such as services, storage, scheduling, leader election, using the same simplified API. Again, thank you, Vladimir Vivien at